Hello, this is Manav, and these are my colleagues Noora and Bishwapa, and we are going to present our Mechatronic System Designs mini project, that is autonomous steering control of wheelchair with drive. So the main objective of our project is to design a smart wheelchair so that physically challenged patients or any other patients can move from one place to another place in basically two modes. That is, first mode is basically joystick mode, which the patient controls by himself or herself, and the second is autonomous mode with obstacle detection. So here two batteries are connected in series, and this is giving 24-volt supply, and this supply is going to the solenoid drive board and also the motor driver board. Also, you can see here we have included a joystick mode for the patient to use and two software-based switches, autonomous switch and power on or off switch. So these two motor drivers are BTS 7960, and these have a power rating of continuous current of 43 amperes, and our motors are basically on full load condition are taking 13 amperes at max. So these motor drivers are integrated smoothly.
So our wheelchair is majorly controlled by the joystick. This joystick is a Hall sensor based joystick, and it gives us the values for deflections in the X and Y directions. The joystick is an analog based joystick, so it gives us analog values, and for processing it in RPi we need digital values. So hence we are using this MCP3008 ADC, which gives us the digital values from 0 to 1024 and helps us to map the values of the joystick into a set RPM value.
We have implemented a PID controller in our system so for the smooth motion and smooth braking, and also it ensures that both the wheels move in the same RPM. The PID controller also ensures that the wheelchair moves at the set RPM no matter what the weight of the person is.
So as we mentioned before, we are using Raspberry Pi as our main controller for the project.
So as you can see, initially, as our steady state speed is 5 km per hour, and that is converted to 40 RPM. So it took 2.5 seconds to settle to 5 km per hour, and you can see I'm moving straight. That means that both the motors, left motors and right motors, are synchronized properly, and both are moving at the same speed. Now I am going to turn right. So I have turned right. It is very smooth control. As you can see, I am moving the joystick. Now for movement of left and right and acceleration and deacceleration, we need to control the joystick.